So let's start. Today I want to talk about hashing in particular and hash tables. Who's that? Can you unmute? Can you mute whoever that is? It's very difficult to switch tabs when I'm on the whiteboard. So please mute. So today we want to look at hashing, but अरे यार कौन है? Avinash, can you mute? I will mute you. Wait. Okay. So let's start. So I will just so far what we have been doing is we have looked at a couple of data structures like arrays, and we have looked at linked lists, stacks, and queues, right? Uh, I will tell you a little bit about hashing and why it came into the picture. So basically, what we have is generally in computers have a lot of data, right? That needs to be stored and processed, and because of that, there is a need to for efficient insertion of data. Then there is a need for efficient removal of data, and there is an efficient need to search that data. Correct? So all these need to be done efficiently over data. And this is why data structures come into the picture. So can anyone just tell me what data structures are? What do you mean when someone, what comes to your mind when somebody utters the word data structure to you? Can I have a couple of unmutes and talking about what is that basically? Organize our data. Yes. So basically, just a good analogy if you want to understand data structures is think about your cupboard or your wardrobe where you have clothes. I know most of colleges don't have wardrobes, but still at homes you have wardrobe where you keep clothes, right? So just think about that. And what do? You organize your clothes in a specific manner, right? So maybe you stack up clothes one after the other, or you put clothes one besides the other. So you stack up jeans first, then t-shirts. If you're a guy, I mean, girls also stack up jeans, but yeah. So you stack up clothes in a specific order so that when you need it, when you need it, you are able to retrieve a particular item efficiently, right? So when you are taking a bath, assuming you are taking a bath, you are changing your clothes, you open your wardrobe, you search, and your search, because you have organized that those clothes in your wardrobe in a specific manner, you are able to search faster, right? Like for instance, if you are planning to wear a jeans to go out, let's say on a date, then you need jeans, and you specifically know that this is the section of my wardrobe where there is a jeans, and I can get a jeans from there efficiently, right? So that is what it is. It is nothing but a container, right? It's a place where you store data. Now just think about it. In computers, where do you store all the data? Memory, right? Memory can be any kind of memory. It can be random access memory, or it can be persistent memory like disks or flash or SSDs, right? So these are the places where you store data, but you want to store data in a specific manner so that tomorrow when somebody gives you a new piece of data, you are able to put it efficiently. You don't take a lot of time in inserting that data item in the container. Similarly, tomorrow if somebody tells you to remove that particular t-shirt, or let's say your mom tells you that it has become outdated, or you've been wearing a particular t-shirt for a long amount of time, then you should be able to retrieve it and remove it from the data structure efficiently. Similarly, when you are going to take a bath, you should be able to find that particular item that you need efficiently, right? So it's all about data in computers, nothing else. It's only about data and instructions. You store data, you need to store data in a specific manner so that these operations are optimized. And this is where data structures come into the picture. As the name suggests, they are structures for holding data, where you organize data in a specific manner so that you are able to do these operations efficiently, right? So now, if that is clear to you, let's look at a couple of ways you could store your data. So now let's see. Let's say somebody tells you that, okay, fine, I understand the reason or the motivation why you need a particular data structure. Let's go ahead with this strategy that we store our data in a contiguous fashion in the memory. So what the analogy for that is, you are storing data one after the other. So you are storing item 1, and then just beside that you are storing item 2, then beside that you are storing item 3 and item 4, right? So this is what? This is nothing but an array where you store data. So what this basically tells you is that you can store data. The structure is such that it allows you to store data in a contiguous fashion. So now let's say this is an unsorted array. So you just randomly, what does that mean in real life? It basically means that you are just putting elements in that particular array randomly. There is no specific order in which you are putting the elements. Let's say jeans first, then t-shirts, then shirts. That's not the order. You are putting, you are, as and when you are getting items, you are putting them. So that's basically the analogy to an unsorted array, right? So let's talk about, our goal is to optimize these three operations: insert, delete, and search for a particular data structure. So let's talk about how much time will it take to insert a particular thing. So let's talk about it. How much time will it take if you are inserting a data item in an unsorted array? Of one, right? You can just keep the next available place in the array. You can just put that particular data item and you are done, right? Now let's talk about the next operation. Let's say you have to remove a particular item in an unsorted array. So how much time will it take?
O of n, I think.
O of n?
O of n.
Yeah. So why? Because you have to find that particular item in that array. So if your array is like this and you have an item ij which you want to find, you will have to traverse the array linearly until you find ij. Once you have found the ij, you need to remove it. So how do you remove it? You put the elements which are to the right of it, you move them one place before. That's how you will be able to remove this particular element, and you decrement the size of the array by 1, right? So this entire operation took order n time. Correct? So deletion takes order n time in an unsorted array. What about searching?
Often.
Searching is order n again, because you just have to traverse the array linearly one after the other. And once you find a particular data item, you can return it. Let's talk about unsorted, sorted versions, the sorted counterpart of it. How much time will it take to insert a particular element in a sorted array?
Of
n, right? Why? Because this array is sorted. So you are basically organizing data in a specific manner. So let's say the data that you got, the positioning of that element or that data item needs to be in the first element, in the first position of the array. So basically you will be, what you will have to do, you will have to like move all the other elements one place to the right, and then you can insert that here. Why is it order log n me?
Sorry, sir, in linked list, no, sir, O of log n won't be there actually.
Yeah, it will be order n for inserting. Because you will have to, so the major overhead is because you have to store elements in a contiguous fashion, you will have to remove the elements which are adjacent to it.
Sir, can we do binary search? So we can do in log n.
You can, what will you do binary search?
Insertion, we have a key and we will compare it with every element. And
you can find that index where you want to put it in order log n. So let's say you found it and this is here.
we have to move the elements.
But you will have to move it so that it takes order n time. Okay. What about deletion?
Often.
Same, order n. Because once you finding, you can do a binary search to find it. That will give you log n. But after you find it, you will have to rearrange the other elements, right? So it takes another order n. And what about search?
Log n.
Search is log n. Correct? So with a traditional data structure like an array, this is basically what the time complexity will look like. Correct? No, anyone has any questions so far? All good? So let's talk about now for a linked list. Now somebody comes and tells you, okay, sir, this is good. I like this idea, but somehow the basic reason or the basic structure that is there in this data structure is that the elements are stored in a contiguous fashion. And I don't like that, because what's happening is if I am keeping all the data elements in a contiguous fashion, the issue that I'm facing is that I have to rearrange elements whenever I insert them or whenever I remove them. So I don't like that. So instead, what you can do is don't put them in a contiguous fashion, but put them in different locations in the memory. I don't care about them, but you can link them to one another just to make sure that you know the sequence. So that is basically what is called a linked list. And then now let's talk about a linked list. So how much time will insertion take in a linked list? Let's say this is an unsorted list. Okay. Just to make things. So how much time will it take? It will take order 1, right? You can insert at here or insert here. It does not matter. Correct?
Sir, but to insert at last, we will have to traverse everything. Right?
I mean, you can keep a tail also.
Then we can do.
That's not a big deal. Yeah. Okay. What about deletion? Let's say you want to delete a particular element. How much time will it take?
Often it has to traverse to that.
It has to find you. So deletion is basically first finding it and then removing it, right? So finding it itself will take order n. You cannot do binary search even if it is sorted. You will have to find that particular element and then move the pointers, correct? So finding it might take n. This might be the last element that you want to remove. So it might take up to order n time. And what about search?
O of n.
Order n. So all these are for unsorted. What about for sorted versions? Insertion will take order n, then everything will be order n for a sorted linked list, right?
The searching can be log n again.
No, sir.
Can you do binary search on a linked list?
Oh, no, sir.
Right? Nothing can be done. So this is for the unsorted and this is for the sorted. For sorted linked list, everything will be order n. Okay. So this is basically now. So yeah, I will mute him. That's fine. So now this is what it looks like with the traditional containers that we already have. We have arrays, we have linked lists, and somebody, if you are about to go ahead and insert, delete, and search in these containers, this is how much time it will take. Now, but the problem is that the data that you get is a large amount of data that you're getting. And in that case, order n is not efficient. It takes a lot of time to insert and delete. Just to give you an appreciation of how big order n is, if you take roughly, if a computer does 10 to the power 7 operations in 1 second, it will take, let's talk about a data wherein you have a roughly 10 to the power 18 data items, correct? If you are taking, let's say, an integer, so these are 4 bytes each, correct? So 4 into 10 to the power 18 bytes is the total size. How much is this? This is 4 into 10 to the power 6 is mega, 9 is giga, right? So right, am I correct? So this will be 4 into 10 to the power 9 gigabytes. If you go ahead, right? Or let's even take a smaller number. Let's take 4 into 10 to the power, let's take 10 to the power 12 data items if you want. And this is basically 4 into 10 to the power 3 gigabytes, which is how much? 4000 gigabytes. So for just think about this much data. This is a 400 GB. This is a 4 TB data, right? For a 4 TB data, how much time will it take? It will take roughly 10 to the power 5 seconds, because 10 to the power 7 operations you are doing in 1 second. Correct? Did I miss something? You have 10 to the power 12 data items, which is roughly 400 GB of data.
Sir,
And
does an operation depend on the size of the data item? Like if we had 10 to the power 12 characters, then would that change?
Yeah, it depends on the operation more than the data. So operation is nothing but 2 operands and an operator, right? Roughly. That's the basic operation that you do.
Insertion would take more time for a int than a car. Like I'm asking, is that true?
Not really, because what happens is you have registers, right? And each register is roughly 4 bytes. I mean, registers the entire data of an integer, the register is able to hold.
I got it. Then it will take the same amount of time.
There is some difference, because when the CPU bus does an IO, it transfers byte by byte. Okay. So, or it does it in chunks also. So it might be dependent on that, but for all primitive data types, the amount of like the size that you have for every particular primitive data type, it really won't matter. Like it will not be appreciable. 1 byte, 4 byte, basically the CPU is able to transfer in one go. The bus basically to the memory or read it from the memory. So it will not affect a lot. Okay, so 10 to the power 12 data items, if I have taken, how much time will I take? Ten to the power 5 seconds. And how much is this? Can somebody tell me? 10,000 seconds. This is roughly 27 hours. Correct? So imagine if you have a 400, I'm just assuming what Utsav said is correct. So just imagine for a 4 TB, let's say you have a data, 4 TB data, and every time you are getting a new element, you are taking about 27 hours to insert. If you have a linked list or an array, that is definitely, you cannot tolerate that, right? So that is basically the magnitude of the problem. So what I'm trying to tell you is that order n and order log n are very, very different. This is log n, right? This is log n. So order n and order log are very, very different. And the shift from order n to order log n is a tremendous shift. It's a very, very appreciable amount of shift that you do.
Sir, 10,000 seconds is 2.7 hours.
हाँ ठीक है 2.7 hours sir. It's still a big number, right? Because you have a lot of insertions that keep coming in. ठीक है? And you have to delete also. Like typically, just think about an Amazon server. If you really want to get a real life understanding, think about an Amazon server and think about how much search requests Amazon gets per second. There are like about a lot of, like if I were to give a number, there are a lot of search requests that keep going for when someone is looking up on Amazon, right? And for every search, Amazon cannot afford to waste about 2 hours to give him the result, right? Do you understand? See what is the issue? Even you cannot tolerate a latency of about 5 to 10 seconds also, let alone hours. Hours is obviously not tolerable. So that's basically the amount of like magnitude of the problem that we have at hand. We cannot, and that's why these structures, these basic structures, although they look very simple and are easy to work on, they don't really work in the real life when you are implementing for real life projects and real life applications. So TLDR version is that we need a better data structure. And we need to do much better. That's basically the TLDR of whatever discussion we have. And then, so now people were researching a lot on this, and there was some great guy, I don't know who, he came up with this idea of hashing or a hash table. So he said, I will provide you a particular data structure wherein on average you can insert in order 1, you can delete in order 1, and you can search in order 1. So this great guy, whoever designed this, he just said that I have designed a data structure. I have a Eureka that I have designed a data structure which enables you to do these operations that you were talking about in constant amount of time on average. Once in a while, once in 1000 times, it might take order n, but for 99% of times, it will be constant. And that's basically what he proposed. And then he died. And people were amazed at this. People were like, oh, wow, this is really like something that could be of a great value add to industries. And that's basically what we will be talking about today, hash tables, which was some proposed by some person, rest in peace. I don't know the name. Okay, so now we have one data structure, a data structure which goes by the name of hash tables, which tells you, which has this USP that it enables you to insert, delete, and search in order 1 time. This is the USP of that particular data structure. And that's all we need to know as a programmer, as long as someone is providing us that hash table.
Sir, sir, are hash tables and hash maps one and the same thing?
Hash maps are a language specific, hash map is a language specific terminology. So if you're talking about hash maps comes from Java, is it?
Sir, I think it is in C++ also.
Yeah. So that those maps we will discuss. We will discuss C++ STL in detail today, at least the hash part. Okay. So just bear. Maybe after that we can revisit this question if by then it does not get answered. Okay.
Okay, sir.
Yeah. So this is basically the USP of this particular data structure, and we as programmers. So now once this data structure was designed, it's basically a container. So for a programmer, I don't care. For me, it is a box where if I insert, it will be order 1. If I delete, it will be order 1. And if I search, it will be order 1. This is what it is. I don't really need to know underneath how the data is getting stored. Like for arrays, you knew that the structure of the data is that the elements or items are getting stored in a contiguous fashion. For linked list, you knew that they are not contiguous, but they are linked to each other. For hash tables, there is some structuring, which we will not talk about now. We will come back to it in some time. But first, I just want to give you an appreciation of what this really is and how much of a value add is this. Yes, so basically, that's what I was talking about, Ashish. It tells you that most of the times it will give you a constant time insertion, deletion, and searching. Sometimes it might give you an order and worst case complexity of inserting, deleting. Okay. So if that background is clear to everyone, or with that context, I will talk about the agenda that we have for today. So first and foremost thing, we will learn how to use this container. how to use this container. This is hash tables, by the way. So now we know the USP. Just keep in mind the USP of a hash table, which is order 1 insertion deletion in average, and worst case it can go up to order n for sometimes, for some cases. First and foremost thing, we will, so because this data structure became so popular,
Sir, for search, it will always be order of one.
everything is order 1 in on average.
But sometimes you said that for insertion and deletion, it will be order of n.
Everything, all the 3 will be order n sometimes, and generally it is order 1.
Okay.
Search, delete, insert, all the 3 are order n worst case and order 1 average case. Okay. So we will come to the implementation, then you will get to know why it is order n and order 1. But for now, just take it as a black box that there is some container that some great man has provided to you, and which has this USP. We will learn how to use it first. So every language has a particular way of implementing this. So every language has an implementation that they have done for that black box, and they give you APIs. APIs are what? Interfaces. So they give you insert, delete, and search APIs through which you can basically you can perform operations on that particular black box. So that's the first thing that we will be doing. So we will be covering a lot of applications of this in questions, and we will see what is the value add that this particular data structure is bringing to us, and how it is speeding up things. What are the different kinds of places where you can use it? And then towards the later half, we can double click on the structure of this. So basically we can see how they are able to guarantee this. Okay, so that will be the second half, or maybe we will see when we will cover this. Okay, all good so far? A lot of monologue. Is everyone fine so far? Do you understand? People who have never heard about hash tables, are you fine now? Do you have some background? Yeah. More acknowledgements. I have 64 people. Assuming I and Gaurav are there, we have 62 people. All right. So now let's look at hash tables and how they are defined, have been defined in C++ STL. That's the first thing that we will be. I did not say anything fancy, Bhagya. I was just talking about what we will be doing. We will first, so what we will be doing, you will get to know now. Okay. So I was just talking about what we will be doing in the, yeah, so it's fine. You haven't missed anything. Okay. So now let's see. So there are basically roughly 2 types of data. So now let's talk about data. Okay. What is, whenever you have data, what is the structure of that data? So let's take some time to understand what kind of data is generally stored in computers. What kind of data is stored? So generally you will have a data with multiple items, multiple values, right? For instance, you might have a data object for a person, correct? So what will that contain? That will typically contain the person's name, that person's phone number, that person's roll number if you are still in college, employee ID if you are in working, and maybe your like house number if you are unemployed. Then name, phone number, roll number. You will have the address of the person where he resides, right? So these are, so this is one chunk of data that you want to store, correct? So now I'm just trying to give you a little bit of like practical outlook of what kind of data is actually stored in these data structures that we are talking about, right? So these data structure, these data items that we store are objects generally. They are not primitive data types like just an integer or just a character or just a string. They are generally objects which contain multiple fields. Like for instance, if you have a repository for let's say all the users that have visited your website, or let's say Amazon has that, then Amazon has data objects for every person, and that data object contains at least these fields or more, one or more of these fields, or maybe even more. Correct? So these data items are what needs to go in the container. This is what we need to do. So these scientists or these research people who, like, I never understand what they do, but these guys who have been who have been researching on this, they came up with two ideas. First things first, they said, okay, what you can do is we have data structures, right? You can store maybe you can store the entire object in one particular location. Okay, that's basically one way of doing it. The other way, they said, is that from that particular data item, you identify one unique identifier. Like for instance, if you were to identify students of a college, roll number could be one unique identifier. You identify that unique identifier, and what you can then do is you can put that unique map that unique identifier. You can map that unique identifier to a particular location in that data structure or in that container. And then what happens is, whenever you have to insert, delete, or search, you can look up that particular item with that unique identifier. And once you have found that particular data item through that identifier, you can retrieve the other fields of that data item and remove everything, right? So these are basically two ways you could store a data. And this way of storing data really caught on, and people really like this way of storing data, that because it's a complicated object, they said that one of the fields could be an identifier. It could basically be used for identifying this data object. And then, so what you can do is basically you can have the entire object somewhere else in the memory. I don't care where it is, but in the data structure where you have to store the data items, you can store that unique identifier and maybe a link to this particular object, so that when you have to find, insert, delete, whatever, you can look up that item by that identifier, and you can access the entire object then and remove it. All right, this picture is clear to everyone? Yeah, okay. So then basically people said that what you are talking about is nothing. So C++ now let's come back to the actual. C++ says that I can give you two types of hash tables. One which goes by the name of unordered sets, and another which goes by the name of unordered maps. And C++ tells you that what this is one container where you can put any data item. That data item may be a primitive data type or maybe an object. I don't care. So if you want to declare a specific container which contains this type of data items, which are basically nothing but the entire data item is stored in that particular location, the entire data object, then you can use this kind of a syntax, unordered set, and in angular brackets you can specify the data type and you can specify a name for it. Let's say as any type. Let's say you had a person's object which was a custom object that you defined. You can have this, and then you can use s dot insert with a person's object. Let's say p1 to insert s dot erase, I think, or remove. We will have to see, to remove, and s dot find p1, let's say, to search. And all these on average, they say that we give you a order 1 complexity of searching of doing these operations on average. Okay. For the other type of representation that I was talking about, wherein we have a specific identifier, C++ STL said that you can declare an unordered map. So basically what this tells you is that you can tell about the unique identifier of your data, which is nothing but a key. So they call it the key. And then you can talk about the entire object, which is the value. So they tell you that if you want to declare any container of this type, you can go ahead and write this keyword unordered map with the data type of the key. Let's say it was, let's say if it's a roll number, it can be a string, and then the entire value. Let's say it's a person, and this could be, let's say, M. So this is how you create one such container, and then you can insert. You can simply insert by referencing it with the key. So let's say somebody's roll number is, my roll number was 12CS30044. So M of 2, 3, this is assigned some person's object. This is how you can insert or update a particular data. If you want to erase, you can simply do a m dot erase. I will have to see the syntax on exactly how you create a tuple. I think m dot cs with just that roll number will be able to remove it. And if you want to find, you can simply do m dot find with the key. So again, let's say it's 12CS30044. You will be able to find the object. Okay, and it guarantees that all these operations are order 1 time again on average. So just to summarize what I did so far, what I told you, I told you that there is a data structure which gives you order 1 average insertion, deletion, and searching. And basically generally we have two ways of storing or representing a particular data. We can represent the entire data in one particular location in the data structure, or we can like represent it as key value pairs, wherein key is some unique identifier for that object and value is that entire object. So if you want to have a hash table implementation of both, for both these types of, or for both these formats of data, then these are in C++. This is how you do it. You have a set, you have a map, and this is how you insert, delete, and find. That's all I have told you so far. Any questions so far? So an object is an object, right? There is no key, Sriram, here. When you talk about a set, your entire data item is the entire object. So you will have to specify the entire object to find it. Right here, you will have to specify the entire person's object to find it.
So, sir, specifying the entire person object would mean specifying all the attributes of that object, right?
Yeah. One object you create of the person, you specify all the attributes that you want to search, and it will find it. So for that object, you will have to have defined an equality operator. The C++ needs to know how you are comparing two objects of the same type. Two persons, how do you compare? You will have to specify that equality. If your equality operator is only on the let's say roll number, then it might return true for two objects with just the same roll number and other fields are different. Then also it might be able to return you true here. It gives you a pointer to that object, which is what we called an iterator, but I will come to that. Yeah. Okay. Any more questions? All good so far? So let's now, if there is any problem with the syntax, let me know at any point. So now let's now see or appreciate what this basically means with the help of an example. Let's take a simpler example. Let's see this question.
So question number.
Oh, fuck, yeah. I just have links, 1 second, I'll just tell you. $149. Done reading? Yeah, everyone is done reading? Yeah, just follow along. I will outline the entire thought process. And let's go with blue. So what the question is telling you is that you have points on a 2D plane. You have points. You have to find one line which crosses the maximum number of points. And you have to tell me how many, like what is the maximum number of points that lie on one particular line. For instance, let's say if your picture is something like this, then this is probably the largest, the line containing the most number of points. So here you will have to return 4. This is a popular Goldman Sachs question, which has been asked time immemorial. Like it was asked to me also when I was interviewing. Even before that, they have asked. Even now, they keep asking this. This is a nice question to illustrate. हाँ मैंने किया था आंसर, मतलब मैंने कुछ कुछ बोल दिया था, फिर हम लोग दोनों सोचने लग गए थे, फिर 10 मिनट दोनों के दोनों, मैं कुछ सोल्यूशन लिख दिया था, फिर दोनों के दोनों देख रहे थे ऐसे करके सोल्यूशन, बट सही था वो सोल्यूशन इवेंचुअली. मतलब if you cannot convince them, confuse them. Okay, so what is the brute force way of going about doing this? Slope of pairs. Okay. So the brute force way of doing it is basically you enumerate all lines, right? You enumerate all lines, and a line can be enumerated by just 2 points, right? And for every line, you can find how many points lie on that line, right? So what you can do is you can consider every pair of points and consider a line that passes through those 2 points. And for other points, you can simply find if those points also lie in this particular line or not. Whichever points lie, you can have a count. So this will basically be the number of points, the number of points that lie on this line. And then you can consider another pair of points, draw a line over it, and check for the other points, whether they lie, how many of them lie on this line, and have your count and keep taking maximum, right? This will be the brute force way of doing it. Everyone understands this? Now let's see. If this is how you, so how much time will this take? N square or more? Why will it take n square? N square is to enumerate a line, but you have to check other points also, right? Whether they lie on this line or not. Right? So this takes n cube time.
Sir,
what is the, yeah, tell me.
So maybe you can try creating a kind of key value pair where key is being the thing, the slope between two pair of points, and value is the count with that same slope, the pairs of point with that same slope, and then we'll return the maximum value of that key value pairs.
I will come to that. Yeah. That's basically what we will do. But yeah, you're right.
So we can do one thing, that if we fix 2 points and make a line, and then for every other points we can check that if that triangle sum is 0 or not. That will lie in one line, right?
Triangle sum is 0. What does that mean?
If that particular point lie on a line, that sum is 0.
Yeah, that's okay. I mean, you can find whether that point lies on the line or not. That's an easy question. That's not a big problem. But the point is, you for finding that is order 1. That's okay. For a particular point and a line, you can find out whether that point lies on that line or not. That's easy, right? That's not the problem here. So what is the problem here? Can someone tell me why is this taking n cube time, and can we optimize it? So the problem is that you take any line every time you take a pair of points on this line, you are redoing the same work again and again. Right? Do you understand this? The redundancy here is that whenever, what we said was we will take every pair, and for every pair we will have a line, and then we will check all the other points whether they lie on the line or not, and we will count how many lie. We will have a counter, then we will update our max, then we will move on to the next pair for the next line. So we will keep doing this. The redundancy there is that if you take any pair of points in a particular line or on a particular line, let's say there were 6 pairs of 6 points, for every pair you will enumerate this line again, right? And you will check these points. So aren't you doing the same work again and again? Here you will be enumerating this line 6C2 times. Right? For this pair, you will enumerate the line, and then you will check whether these points lie on the line or not, and these points also. Then again, for this pair also, for this and this, you will enumerate a line, and then you will check whether these points lie on it or not. Right? So you are doing the same work 6C2 times for this line, whereas you could have just done it once. Right? Do you see the redundancy here, first of all?
So there can be a case where only 2 points are there on one line for every pair of points. So still,
okay.
are we doing more work in that case than the amount needed?
We will come to that. Let's complete the algorithm. Then we will revisit that corner case that you are talking about. Okay. Others, do you understand this redundancy that I'm talking about? Where are the others? Are you thinking on your own? Right? Do you understand this? The same computation you are doing again and again. So what could be one way of optimizing this? One way of optimizing this could be that you have a container. I have not introduced slopes and intercepts for now. Think about the problem more abstractly. That really helps. Why are you like going into the technicalities? We will come to it. So now, how can you optimize this? One way you could optimize it is that every time you get a line, you can put it in the container, right? So that whenever you encounter again a line with 2 different points, you don't really have to find that line again. Right? Or what Utsav is saying, we will keep track of which line it is a part of. Yes, that's also one way of thinking about the same thing. So here, basically, the redundancy was that you were enumerating the same line for every pair of points on that line. So why don't we do what Utsav is saying, that for every pair of points, for every point we know, if we know which line it is a part of, then we will be able to optimize this. Is this clear somehow? Or I can explain again, yeah.
But a point can be a part of many lines.
Yeah, a point can be a part of many lines, which is fine. We can track it for multiple lines, right?
So you are saying is that we first generate all the lines, and then for each point we maintain basically maintain a counter and keep like check for each point. For each line, does it satisfy or not, and keep incrementing the.
No, wait. Let me explain again. Just don't go in that direction. what I'm saying is that you have a line. If you have already enumerated a line and found out how many points lie on this particular line, when you are taking another pair of points and enumerating a line, if that line is already some line that you have enumerated, why do you want to enumerate it again? You can simply skip this, right? That was the redundancy. So that is basically what I'm saying, that for every line, so what your algorithm should look like is, we are just taking care of the redundancy. What was the redundancy? The redundancy was that the same line was getting enumerated again and again for different pairs of points. So now what I'm saying is, for every pair of points, you enumerate a line. Okay. If that line has already been enumerated, you put it in the container. So if it has already been enumerated, then you don't enumerate it again. You can simply skip for that. And if it has not been enumerated, then you enumerate this line and check for the other points also, whether they lie on this particular line or not, and get the count. Correct? Does this make sense? Everyone? So now, if that is how we plan to do this, then what is this? What are you expecting from this particular container? You are expecting that whenever you get a line, you are expecting that you will check that line, whether that line is already present in it or not. Correct? Which is basically searching. What else are you expecting from this particular container? You are expecting that you will be inserting a particular line once you have enumerated it. Right? So these are basically the two operations that you will be doing on this container frequently. And if these are the operations that you want to optimize, the first thing that should come to your mind is a hash table. That can I have a hash table or a container, or a hash table as the container for this type, for this. Right? So far? Do you understand how I arrived at the idea that I will use a hash table? The entire breakdown, I just told you a problem. I told you a brute force way of doing it. I showed you some redundancy in that problem, that the redundancy is that the same computation is getting done again and again, which can possibly be skipped. And then I told you that why not store that computation somewhere, so that whenever you are going to compute it again, don't compute it if it has already been done. And from there, I abstracted that I will use some container of this type. From there, I just looked at what kinds of expectations do I have from this container. So I will have a searching expectation and an insertion expectation. And from there, I concluded that because I want to do these things efficiently, I will use a hash table. So this is basically the entire thought process. You can ask me questions on any portion of the thought process. Yeah.
Sir, if there are n points,
Mm-hmm.
then that at max there can be NC2 lines.
Yes, there can be NC2 lines. Yes. Okay.
That if this is the case, means that there are NC2 lines, then there will be no third point on any line.
But you will still go ahead and check, right?
And sir, so NC2 lines means order of n square.
But you will still go ahead and check whether the other points lie on this line or not.
Yes, sir, we will check.
So that will take another order n for all these NC2 lines.
So means in total the time complexity will be of order of n cube.
N cube according to what we have like previous algorithm.
Sir, but according to hash map for this condition, what will be the time complexity? Means there are NC2 lines.
Okay.
Then what will be the time complexity?
Yeah. It will go up to n cube then. You're right. If you are, yes, you are right. Yeah. Do you get what Rahul is saying? Does everyone get? So Rahul is saying that if you have a point for every NC2 lines, if you have NC2 n points and there are NC2 distinct lines, so every pair of point has a distinct line. So in that case, you will how much time will this take? This will still take n cube time, right? This algorithm.
सर मतलब जैसे स्क्वायर वगैरह हो गया.
No scope for optimization now, because we have to draw every line.
Yeah, I mean that's the least you can do. इससे अच्छा आप नहीं कर पाओगे ना इस केस में, क्योंकि because unless you find out every point is getting visited only once, right? Is there a scope for optimization here also? First of all, do you get what Rahul is saying? Everyone? Mehak, do you get it now? Or Dhwanil or Devang?
Sir, even if there are only 2 points on one line, we don't have to draw that line twice, right?
We don't have to draw that
No,
line.
but for defining a line, we need 2 points. So there will be n square lines.
There will be n square lines, yes. Devang, what is not clear? Do you understand this case that what we are doing is, do you understand the algorithm that we are
Yes,
seeing?
sir. Yes, sir.
So if that is the algorithm, one case that Rahul told is that let's say you have n
N-sided
points.
polygon. Sir, n-sided polygon ले सकते हैं.
हाँ, n-sided polygon ले लो आप. ऐसा है, let's say you have something like this. Let's say a square.
n square समझ में आया. n cube क्यों हो जाएगा?
n cube क्यों हो जाएगा? Because the algorithm is कि you are enumerating a line and you are finding out all points that lie on this line, right? You are getting a count.
Isn't this supposed to be like O of 1 if we are using hash tables?
Yeah, we will. No. So with this algorithm, what will happen is what was this algorithm? This algorithm was you have a line, you will enumerate a line for a pair of points, and then for you will check for the other points whether they lie on this line or not. And once you have enumerated this line, you will put it in the hash table, and then you will take another pair and enumerate another line.
Okay, sir.
Right. So every time it will be n cube, right? For every pair of lines, you will check for the others.
Right.
So it will be n cube. Map of line plus plus, what is that? If you get, you are incrementing the counter of that line. Yes, Dhwanil, this should be the worst case. Mehak, is it clear now what Rahul is trying to say?
Yes, sir.
Sir,
Yeah.
what's the time complexity of your algorithm? This one?
This is basically how many lines are there, correct? This algorithm that I have told you is currently
Yes, sir, this one.
the number of lines that you will enumerate. Let's say that is k, so it will be k into n, right? Every line you will enumerate and you will check.
So what is k? Means k is the number of line.
K is the total number of distinct lines that can be found from those points.
Okay, sir.
Yeah, can we optimize this? So Chidambaram has an idea. What is the idea? Chidambaram, can you unmute and ask? Say.
Yeah, sir, for every line, After finding the line, we can increase in the map, and finally we can loop through the map at the end.
That's okay, but
We
for
are not
every,
checking after generating line. We are not checking for every point. We are just storing in the map, increasing the counter. So therefore, only NC2 lines will be generated, and they can be. We can store them directly without any other loop for checking which points lie on that line.
right. So what I got you, that's basically the third part that I was about to tell you from here. So this is one algorithm. Okay, let's go sequentially. So I told you the brute force way of doing it. Then I told you if you store the lines, then you can probably, what are you doing here? You are storing the lines and you're enumerating a line exactly once. Correct? Enumerating a line exactly once. This is the second algorithm. This takes k into n time. This will take n cube. So k can be worse nc2. So in that case, this will take n cube time. Can we do even better than this? So this third idea will basically come from here. Does anyone have any ideas around this? Now it should be easy. Now the transition from this to this would be easy. Like even if you if you've heard what Chidambaram said, then yes, it will be much more easier. But still, even if that's not the case, this is easy. Can you optimize this to get n cube, n square, like somehow?
Sir, what I was thinking,
Mm-hmm.
like if there are if there are 4 points on a line, so say for example,
Mm-hmm.
then we will get exactly 4 C2 pairs.
Mm-hmm.
4 C2 pairs, which will correspond to the same line.
Yes.
So what I was thinking, like every time we encounter a pair having same line,
Mm-hmm.
we increment the count of that line. Basically, a line will be stored by a map, and
Yes.
and at the end, suppose that line contains x points, then
Yes.
xc2 will be the value of that point.
Yeah, you're right. We will do something similar. What you're saying is exactly what I mean, along the similar lines.
Yeah.
So here what we were doing, for every pair, we were enumerating a line, and then we were checking whether other points lie on this line or not. If once we have done this, then we were putting this in the hash table so that whenever we pick another new pair of points and generate the same line, we don't have to do this process again, right? This is what we were doing in the previous algorithm. Now, can we optimize this even further? So think about this container. This container is keeping lines. And what you are doing is now you have a brand new line. So the idea is from here to here, what this algorithm is doing is you are enumerating a line from a pair, and the second step you are doing is you are checking other points whether they lie on this particular line that you have enumerated or not. Can you avoid this step? That's basically the hint for getting into an n square solution. Can you somehow avoid this step? So you will enumerate a line, but you will not check whether these points lie on the line when you have enumerated this line. You can check whether this pair, a particular pair, lies on this particular line or not when you are enumerating that pair, or when you are enumerating a line for that pair. Do you get this idea somehow, somewhat? Anyone?
Yes, sir.
Sir, is it the thing that I asked at the beginning? Like,
Okay, what was it?
sir, I was asking that we'll for every pair we'll just calculate its slope, and we'll store every pair like slope key value pair by key was the slope,
Yeah,
and
yeah.
value was the.
That's what you're saying. It's the same thing.
Okay.
Yeah.
Sir, why do we even need a key value? Can't we just keep the slope, and if the slope is same,
No,
we increment that?
we will come to implementation. Don't worry. Let's go step by step. We will come to the implementation. I'll justify why we need a key and a value. So the point is that from an n cube to an n square, there is even more redundancy here. The redundancy here is that when you enumerated a particular line, you checked for other points to lie on this line, and then when you enumerated this line again using this pair, then you are doing the same work again, right? Which is what you can optimize. How can you optimize that? You can optimize that by whenever you enumerate a line, you can just put that line in the container. You don't really need to check for other points whether these points are lie on this line or not. You just put this line in a container and you say that currently the number of points in this line is 2. Okay. Now, whenever you go through another pair, if that pair results in the same line, then you can increment this count.
Sir, I think we cannot. So suppose the points are redundant.
We will take care of the cases. What redundant as in the same point?
Yes, sir. Suppose A point is a pair with B and A point is with C. So A will be incremented 2 times, no?
Yeah, we will take care of that. I'm just telling you the idea. That's okay. Increment it by 1 or 2 is another thing. I'm not talking about that right now. I'm just giving you the idea right now that what is the optimization that we have achieved here. The optimization was that in the previous case, what we were doing was for every line, we were checking whether other points lie on the same line or not. What I am now telling you is that you don't really need to do that also when you enumerated that line. Take care of that when you are enumerating the line for this particular pair of points. And if you are enumerating a line somehow which you have already enumerated, then you can simply increment the counter accordingly for this particular line. Correct? And then this will give you an order n square solution, because you are just enumerating every pair and looking up the container. So I will just take a pause. Can I have acknowledgements for people from people who understand 1, 2, and 3 and how we reached sequentially, systematically from 1 to 2 to 3? That's very important. The reason we do this exercise in the class is because it's very important that you understand how you should think. I could have straight away told you this solution, you would have agreed, and yes, we would have coded it and fine. That's okay. But that's not the point of doing these questions, right? This is how you incrementally think. And if you can do this in the interview, then it's nothing like it. They'll give you whatever amount you are asking for. Bhagya, you don't understand 2 and 3. Okay, I will very quickly just summarize. So brute force, everyone understands, right? Brute force is basically we are enumerating. So brute force was, I was just enumerating every line, and for every line, I was checking whether other points lie on this line or not, and then taking account and and updating. So that was one. The second was that I said that the redundancy, the inherent redundancy here is that you have, when you are enumerating a line for this particular pair of point, you are enumerating the same line again, right? And you will do the same work again for even this pair. So why can't you simply, so this was NQ, why can't you simply skip enumerating the line and checking for the other points, whether they lie on the line or not for this particular pair, because this line has already been enumerated and you have already considered it. So we said that in, so what you can do is you can store these lines as and when you have enumerated them completely or with all the points. And if you do that, then basically whenever you encounter a different pair of points which enumerate a line which you have already enumerated, then you don't go ahead and enumerate that line. So this will basically take order k into n time, where k is the total number of lines that are possible. And n is because you are searching, once you have enumerated a line, you are checking whether the other points lie on the line or not. From there, I reached solution 3, wherein I said that there is a redundancy here also. What is the redundancy? The redundancy here is that when you have enumerated, when you are enumerating a line, why are you are doing what you are doing is you are checking whether these points lie on this line or not. And then at a future time, when you are enumerating this particular line, then you are doing the same work. So can I skip that? So from there, I got this idea that, okay, let's not do that. What we can do is we can just, whenever we can just go over the pair of points, and every time we get a line from a pair of points, if that line already exists in the container, what I can do is I can increment the count of the number of points on this line accordingly. So this basically will now give me n square time, because I am just going over all the pairs. Yeah, Prapti, now do you understand? Okay, so now so this is the algorithm then. Once I have thought about the algorithm, let's look at how we can implement this. How to go about implementing this particular algorithm. The algorithm is you can iterate over every line, iterate over every pair of points, and for the line that it generates, you can simply increment the counter of that corresponding to that particular line in a which is stored in some container. And we have already decided that that container that we'll be using is a hash table, because this is we are constantly inserting and searching in it. First things first, what is the representation of a line? How can you represent a line mathematically? Yes, y equals mx plus c. You can have a slope and an intercept. Okay. Okay, now let's see this. What are we doing in this algorithm? In this algorithm, for every pair of points, we are checking whether this line has already been enumerated or not, right? And if it has been enumerated, then I'm incrementing the counter. So for every pair of points, when I'm checking whether this line is the same as this line, Do I need to store both of these to increment the counter or to find it? Both slope and intercept? Or can I get away with just the slope?
No, sir.
Why?
They could be parallel lines.
They could be
Could be
parallel.
on parallel lines. Sir.
Yes. So I will need to store both slope and intercept. Okay. Now, this is just one thing. Keep in mind, we will come back to this. Now let's talk about the order of enumeration of pairs. So we are enumerating every pair, right? Let's say I tell you that, sir, what you can do is when you are enumerating every pair, what you can do is you can fix one pair, 1 point, and for this point, you can just enumerate, take every other point and enumerate lines. And do the same thing that we are doing here. Okay. So, and then what you can do is then you can move on to the next point. And for that particular point, again, you can enumerate all the points. You can fix that as one of the points, and then you can enumerate all the lines with that point and a different point. If this is the enumeration order in which, or if this is the order in which I elaborate or enumerate all the points, all the pairs of points, then what information do I need to store to represent a line here? Do you get this question? We just discussed that to represent this line, yes, you will need a slope and intercept, so that every new pair you encounter, you will have to check whether this particular line has the same slope and intercept. Now I'm just telling you, this is fine. Yes, you can do that and you can go happy. That will be one particular implementation and you will be fine. Now I'm just telling you that if I order so you will enumerate these pairs in a particular order, right? So now my question is, if I enumerate the pairs in this order, I'm not picking any 2 points randomly. I am fixing 1 point and then enumerating all lines for the other points. So keeping this as one of the points and the other point as the other end of the line or the other points of the line. If I am enumerating in this manner, and then I'm changing my first point again to, let's say, this, and then I'm fixing this and I'm enumerating for others. If this is the order, first of all, do you understand this order of enumeration? This is like the common way we enumerate pairs, right? So my question to you is, if I enumerate all the pairs in this particular fashion, do I need to store both the slope and the intercept? Why?
So because 1 point is fixed, now if we take any other point and if they both lie on the same point, like say A and B and C are there, if 1 point is fixed and the slope for AB and AC are equal, then they will definitely lie on the same line.
Do you get this? Does everyone get this? We can get away with just keeping the slope now, and we don't need the intercept because you have fixed a point, right? So all the lines that come from this point will have, you can just have a slope to represent all these points, right? Or the other way to put it is what I was saying. You take any
Sir,
two.
but imagine there are 4 concurrent points, say 1, 2, 3, and 4. and then we repeat this activity for all 4 points.
Come again. 4
Four
concurrent
concurrent points. So 1, 2, 3, and 4.
What does that mean? Concurrent in the sense?
Sorry, collinear.
Collinear. Okay.
Yes. So for one, we'll do this activity, and we'll have like we can get away with 2, 3, and 4. So we know that 1, 3, and 2, 4 are like on the same line because we've incremented the counter. But 1, 3, and 2, 4 could be on different lines, right?
Come again.
I mean, if we're like, as long as we are doing this for 1 point, it's okay. We can get away with like storing only the slope. But when we want to compare different points, like for lines passing through 1, lines passing through 2, like this is what we are essentially doing, right? We are like enumerating all lines passing through 1.
We
Then
are
all lines
enumerating
passing
all
through
lines
3.
passing through 2. Yes, you're right.
So how do we know that the line with slope m that passes through 1 and 3 is the same line that with slope m that passes through 2 and 4?
So once
We
we
don't
have
have the
enumerated, all lines that pass through 1, we can refresh the hash table and then start enumerating all lines that pass through 2.
But then how do we keep a count of what line has what number of points on it?
No, we will keep a count. So when we have enumerated, let me complete the algorithm.
Okay, sir.
We will see. So that's what Utsav. We will come to that. That's the third point. Okay. So 1 and 2 are clear, right? So let's talk about the next issue. So I tell myself that, okay, this is the order of enumeration that I want to. So I want to enumerate all lines starting from this particular point. And once I am done, enumerating all lines with this particular start point, I can move on to another point and enumerate all lines passing through that particular point.
Sir, doesn't we have overlapping subproblems here we are recalculating the same?
That's not overlapping subproblem, that's redundant subproblems. You don't need to calculate it. It's not that you need to calculate it and you, right? That's redundant subproblems. That's a difference. Okay. So now let's say, so what is the issue with this? If I keep the same slope, the next time what I will do is I can enumerate. So the problem with this is that when I move on to the next point and if I happen to enumerate the same line again, then my counter I will increase the counter again, right? Which will lead to like extra points, which are redundant points. Right, Utsav? Is that what you're trying to say?
But sir, we can take care of that.
Yeah.
Yeah, sir, that will not be a problem, I think so.
Because it will be included, like if at the end, if it has 3 points on the same line, then its value will be 3C2. So at the end, we can check that value and reduce that value to get our answer.
Yeah. So basically, we said, so what have we said so far? We said that let's enumerate in a specific order. Let's enumerate all pairs with fixing 1 point and do the same exercise that every time we get a new line, every time we get a line, we increment accordingly. And then what we can do is we can move on to the next line, the next point, and again enumerate all lines which pass through this. So now if you are doing the same thing again, what you can do is at the beginning of enumerating this line again, you can clear this container. Correct? So that now when you have this point as the first point or the starting point for all the lines that you are generating, you can, every line that was already generated before, you don't really need to be bothered about it. You will not be increasing the count again of that particular line. Right? So basically what you will do is you will be generating, you will be generating obviously those lines which have, some of those lines which have already been generated before, yes, but other than that you will be generating new lines for which of which you can keep taking the maximum. Right? Do you follow this clearing the container part? Who does not understand this? So Akash, the problem is, see, the problem is what was the original algorithm? The original algorithm was that we will enumerate points in a specific order. So we will enumerate all points starting with this point, enumerate all pairs starting with this, and whatever lines we are getting, we will in the hash table, we will have counts for this. So let's say this is line L1, L2, L3, L4. You started with A. These are, let's say, B, C, D, E, F, and G. So what you are doing now is you are enumerating all pairs with A as the first point. So once you enumerate AB, you will get a new line. So you will put it in the container with count as 2. Now you enumerate C and you enumerate AC, right? That line, and you see that that particular line is already there. So what you can do is you can increment this count by 1. Okay. Next you go to D. So now you go to D and you get a new line. So you will put this again, AD, this line, and you will have a count of 2. So let's say this is AB and this is AD. Now you will go to E. So where was E? Let's say this is E. So AE, you will get another new line which is not there. So you will put it in the container again, AE, and your count is 2. Now you will enumerate F. Now you get another line, AF. You will put it in the container and the count will be 2. Now you will enumerate G, AG. So you will see that this line is again still already there. So you will just increment it by 1. So now you have these counts 4, 2, 2, 2. The maximum of all these is 4. So you will keep taking a maximum as you encounter a new point, you have a 4. Now the problem with this is now when you are enumerating B, what will be the scenario? Let's say B is only let's say there is one more line passing through B. Let's say this is the line. Let's say B and D are connected. That's it. Let's just say this. So now when you are enumerating B, you will consider A also first, and you will generate a line with B as the point and A as the point. You will find that that line is already there, and you will happen to accidentally increment the count by 1. When you enumerate B and D, this line, then you will find that BD is not there. You will put it in the map and you will increment the count by 2. You will initialize the count by 2, which is fine. So every new line that you enumerate, starting with B as one of the points, which has not been enumerated before, you will be fine. But for every line which you have already enumerated before, if you happen to enumerate it, then you will be incrementing the count again, which is basically redundant or wrong.
Sir,
Right?
but then if the counter is increased, the count like in this fashion, like 5, 6 and onwards, it will finally end at a value which is KC.
You can still do from there also, right? Come back from there also. Yeah. Yeah, Devang, I got you. So to avoid this, what you can do is you can simply clear the map. when you are enumerating for B, simply clear the container. So empty this. Start with a fresh container now. So what will happen? You can enumerate this line again, redundant, which is fine. I don't care. But for the new lines, you will, and this, you can again keep doing the counts and you can keep updating the maximum. Right? Does everyone get this?
Hello.
Yeah. Yeah, Devang, I got your point. Yeah, but I got your point, what you're trying to say. You can still come with that value also, you can calculate the original number of points, right? Because every point will be considered n minus 1 times, like when you are enumerating it, right?
Right.
Yeah, you can do that. I got it. Which part, Dhanil, did you not understand?
Sir, why are we clearing again? Sorry.
Why are we clearing again?
Why are we clearing again?
So we are clearing because the next time you generate, you can generate the same line again, right? From these 2 points also. So you have already generated the line A, this line, and you have incremented the counter for this point, this point, this point, and this point. Now, when you consider B as one of the starting points, you could generate the same line, right? With C again. So you would increment B again and C again here. Right? Which is not right. I mean,
Yes.
so 2 ways you could avoid it. You could, in the next iteration, when you are considering another different point, starting point, you could clear the map. That's one of the ways. The other way is you could keep counting. You would eventually, once you have a count, you know that this count basically, you have arrived at this count by, let's say there were k points in this line. You have counted this k minus 1 times. You have counted this k minus 1 times, right? And so on. So this is basically k into k minus 1 is what your result is. So you can get k from there also. Right, Devang, this is what you are saying, right? Like roughly, my math might not be right completely.
Sir, can we maintain a set for each line in which we keep on inserting the points as and when they come?
You can insert the points, but so you will maintain a set for every line. Yeah, you can do that. That will take more time, right? In the sense that insertion, yeah, theoretically insertion is order 1. So you should be fine. But eventually you will have to keep a count also, right? Or after that iterate through the set and count.
Yes, sir. So after completing the process, we iterate through each of the sets and the maximum value of the set that we obtain is our answer.
You can do that, yeah. Just think about the complexity, whatever it is. Okay, so this algorithm is clear to everyone. Can I have final set of acknowledgements before I go and code it?
Sir, what's the parameter we are using when we are storing the line? Is it just the slope?
Just the slope, because I am enumerating the lines fixing 1 point. And then I'm clearing it, and then I'm enumerating another set of lines fixing 1 point. So when I'm enumerating,
so because 1 point is fixed, so means the slope remains same here for all.
The intercept remains the same for all the points. Not the same, but there can't be 2 parallel lines with the same slope, right?
For parallel lines, I think the fixed point will change.
Yeah. If you have 1 point from where passing through which all the lines pass, you cannot have 2 parallel lines, right?
Yeah. Okay, so yeah.
That's it.
Sir, you will clear the map after every iteration.
Yes. See the code. Things will become clearer.
Sir, so what would be the time? Like, won't it be n cube?
The clearing the map will be. Why will it be n cube? It will be n cube.
So suppose like there are NC2 points, like there are no.
Yes.
So
yeah, but
if we clear at every step, then
you are not clearing at every step.
Clearing at each point, right?
No. So think about it in this way, that you are only clearing n square times maximum, NC2 times.
Yeah, but clearing will itself take the size of the number of slopes, and that can be n square. Like if we have the regular polygon thing, like every time we will have n square of n square lines.
Will you have n square every time? If you have n square once, the next time will you have n square again?
N into n minus 1 into n minus
1. Why?
Sir, because no points are collinear. Like for first point.
So what is the your base case, extreme case that you are giving is all the lines are distinct, right? Like you have a different
regular
line for
polygon.
every pair. Yeah, regular polygon or something. So in this case, when you are enumerating for this particular point as the starting, you will get you will get n minus, so let n minus 1 lines, right?
Yeah.
N minus 1 lines. So you will clear that.
Yeah.
So fine.
So for next we will again get.
Yes. So you have an outer loop, in that you are clearing, and then you have an inner loop.
Yeah.
तो इसका कॉम्प्लेक्सिटी कितना है? अगर ये मैक्सिमम n जा रहा है तो ये टोटल n स्क्वायर ही है ना, ये पूरा, ये n क्यूब थोड़ी है, right?
Right.
Do you get? But that's a very valid question that comes to many minds. This is n square, worst case. This will not be n cube. Why? Because think about it in this way: starting from a point, you can generate a maximum of n lines, right? N minus 1 lines, if there are n points, and that's basically what you will be clearing here. So maximum at every step, you are clearing a map of size n. And so this is n, this total is n. So this is n square. Let's code. You will get it. But yeah. Okay. Let's see. So first things first. First things first, let's take
question ही दूसरा है.
Sir, question.
क्या question दिख रहा है? नहीं दिख रहा है.
दूसरा
क्वेश्चन गलत था.
अच्छा, फ्रैक्शन टू रिकरिंग डेसिमल खुल गया क्या? ठीक है, वो वाला भी करना है वैसे. ठीक है, दिस इज फाइन नाउ. Yeah, first things first, let's take the name of God. Now let's go. So you have the number of points is this, and you have two indices for which the order for the order. Now see, we are keeping a map. This map will basically be of, you will have a slope. So how do you keep a slope? Float is not the right way. I will come to that. So why can't you keep float? Because that's wrong, right? The best way to keep it is as a string and keep it as m by y by x. And then you will have another data type for the value, which is the count. So we have an integer here. Let's keep m here. Now let's see. So first things first, let's go over all these. So let's fix the first point, which is what we have done here. Let's go to the next point. I mean, we can, this will not really affect. You can start from 0 also if you want. I can start from I plus 1 also. It really does not matter, because sum of because some of the lines that you have already enumerated, even if you are not enumerating them, it's fine, right? Because you have already considered them when you took the other point as the first point. So this should be fine. Now let's get the slope. So let's take x, y. So y is points j 1, right? Minus points j 0. X is points j 0. I1. Sorry. I0. Right? Let's call them dx dy because they are differences. Dy by dx is the slope, right? So now let's construct the string. So slope is you will have to do one thing before that. Can somebody tell me?
GCD से divide करना पड़ेगा.
GCD से divide करना पड़ेगा. Does everyone understand this? Right? 4 by 6 and 2 by 3 are same. So you will have to normalize it basically. So how do you normalize it? You can divide it by GCD. So let's write the code. So the code is if
Sir, inbuilt function.
inbuilt होता है क्या? लिख दिया. Underscore GCD. Okay, we can do that. Let's see. Let's say factor. Prapti, do you understand why can't we take an int? It's a slope, right? It's y by x.
Sir, difference 0 भी हो सकता है तब GCD error दे देगा.
क्या difference 0 भी हो सकता है? मतलब you are talking about. Let's take the cases first. Let's write the skeleton. Then we will come to the cases. So this is the slope, right? So what are the cases? You will first try to find this. So you will find this slope. If this slope is found, what it does is so if it does not find it, basically it returns an iterator which is pointing to the next element after the last element in the map, which is basically which you can represent by m dot end. Okay, so if I find it and I don't get an m dot end, that basically means that I have found this slope. Do you understand this m dot end, or should I explain this? Can I quickly get votes from people? You got it, right? Okay. So if this is found, then what I can simply do is I can increment it for this point. If I don't get it,
Sir, what is the use of m dot n?
what is the use of m dot end? M dot end is nothing but it's a way of telling that I did not find it. So what it tells is this is basically pointing to it just gives you the end of the container if it is not able to find it. and as in the element, the position just after the last element. Okay, it's just a way of telling that I did not find it. So I can just increment the container. Otherwise, I can do this. Let's take care of, there will be cases which will be painful. Okay, and there will be a global max. Let's start with 0, which you can update every time actually. In fact, let's just update it outside. Max count. Max count is nothing but max of max count, comma. Right, so I'm just taking a max for this loop, for this point as the first, and finally what I can do is whatever I got, I can take a global maxima for across all the points. I can return this. This is just the skeleton. There are cases which I need to handle, but first of all, is this basic skeleton clear? Whatever I have written so far, right? This is clear. Yes, we will do an m dot clear here. Other than that, everything is clear. We will take care of some cases which can arise, and unfortunately for this question, they are valid. So we will have to take care of that. But before that, at least the basic raw logic is clear, the raw implementation. Others? Clear to everyone, right? People who knew maps, people who did not know maps.
सर 2 मिनट स्टेयर करने दो बस.
हाँ घूर लो अभी चेंज करेंगे अच्छे से इसको. Now let's take care of some cases. Tell me what cases can arise which can potentially lead you to troubles.
Slope is infinite.
Slope is infinite. So y is 0. Correct? And duplicates. So what do you do with slope 0?
We can define the string to be 0, like slope string to be 0. If dy, if dx is 0, we can define slope to be 0. If dy is 0, we can define slope to be any special character.
Yes. So what we can do is we can put all this in that if, right? And then everything will be fine. So what we are saying is that if dy is 0, if dy is not 0, right, Geetans? Is this what this will work, right? For infinite slope. Now let's take care of 0 slope. So for 0 slope, what's the issue? That the GCD will come out to be, what will be the issue with a 0 slope? Did you get this first of all? Is this right?
Sir, what if dx is 0?
Yeah, we're taking. I just took care of dy 0, which is basically infinite slope.
In this also.
अच्छा, infinite slope is dx 0 ना. हाँ ठीक है. मतलब I just took care of dx0. Yeah, my bad, sorry. What if dy is 0?
So if dy is 0, factor will be 0.
Factor will be 0, is it? So
Factor
GCD of 9 and 0, what is it?
factors will not be defined.
Yeah, I mean, basically GCD will still be fine. This GCD will at least be fine. In fact, I guess the STL's GCD will also be fine, right? For 9 and 0, it will give 9 as the GCD. Yes, because X will be able to, X is the factor. X is a factor of 0 also, right? X divides 0. X times 0 is 0. And X divides X also. X into 1 is X. We will come to duplicates one at a time. So I guess for dy is 0, we are good, right? We don't need to do anything. For dy 0, we will get a factor which is equal to x dx, and then this becomes 1 and this becomes 0, which is fine. Then I will be constructing the string and everything will be fine, right? So dx dy ho gaya 0, I guess. What is the next case?
So, sir, if dy is 0, we will get different values of slope for different dx.
If dy is 0, we will get different values of slope for different dx. We will not. We have normalized it, right? So if you take 1 comma 0, let's say 1 comma 2 and 9 comma 2, let's just take on the x-axis itself. Let's say you are taking 1 comma 0 and 9 comma 0. The slope is we are putting in 1 by 0. We are not putting in 8 by 0 because we have normalized it. So next time if you get 11 comma 0, we will put 1 comma 0 only for that. Yeah. So I guess that should be fine. dy 0. And for dx 0 also we are fine. Now we have handled it. For dx 0 we can simply put for dx 0, have we done enough? Or for dx 0 also we have to normalize? Do you get me? So for 9 comma, if you want, for 0 comma 1, 0 comma 9 and 0 comma 15, all these are on the same line, right? So what are the slopes for 0, 1 and 0, 9? 0, 8, 8 by 0. And what is the slope for 0, 1 and 0, 15? 14 by 0. If we are not normalizing it, we will run into the same issue. Correct? So we have to normalize. What will be the GCD of 0 comma, what will be the GCD of 14 comma 0?
सर एक्स एक्सिस वाले पॉइंट्स के लिए dy will be 0 not dx.
हाँ ठीक है.
तो केस कंसीडर हो जाएगा ना.
और y एक्सिस के पॉइंट्स के लिए
स्लोप 0 तो वैलिड है.
y एक्सिस के पॉइंट्स के लिए वी आर टॉकिंग अबाउट इनफाइनाइट स्लोप ना.
ओके
14 ही होगा तो आई थिंक ये चेक नहीं चाहिए. या तो ये कोई बोला नहीं मेरे को. ठीक है. Does everyone understand why this check is not needed? Everyone understands, right? No problems. So dy dx, both normal, both corner cases we have handled. Let's take care of the final case, which is if you have duplicates. So in case of duplicates, you will have both of them as 0 because the points are same. How do you handle duplicates? डुप्लीकेट मतलब सेम पॉइंट वापस आ गया तो ऐसा
Skip
दिया नहीं
करेंगे
ना
उस
कि
point
एन डिस्टिंक्ट पॉइंट्स है. स्किप करने से काम कंप्लीट नहीं होगा बिकॉज हियर when you are doing a max count you will have to include those points also. Correct? So one way of doing it could be हाँ ऐड करना पड़ेगा. तो one way of doing it could be just keep a count of all the duplicates and when you are taking the max here you can do max count plus duplicate.
So what if both those points are not on the line having the maximum points?
Both which points?
Like the duplicates are not on the line.
No, it will be on the line. We are enumerating all lines starting from this point. It will always be that case. Right? So one way we could do it is we could keep a count of all the times we are encountering A. A is the first point. And we can add that here and keep this as 1. So what have I done? I have simply told you that whenever I am putting a new line, I am just putting incrementing the count for this point every time. And I'm just keeping a count of every time I'm encountering this point. And towards the end, I am just adding it here.
तो सर फिर तो फाइंड की भी जरूरत होती है उसके बिना भी कोई सर if you are not putting m slope equal to 2 तो सर फिर वो फाइंड वाला जरूरत नहीं थी सीधा m slope प्लस प्लस से भी चल जाएगा फिर
हाँ चलेगा करेक्ट you're right but let's just keep the code more readable. ठीक है? So will this be fine? Anything else that we have missed? God will tell us. Yeah, so I'll repeat the duplicates wala part. First, let's ensure that the duplicates wala part is correct. This is 0, 0, 0, 0. So just need to take care of this. So how can you take care of this? You can, this is easy, right? If you get a factor of 0, if both the points are 0, that edge case we did not handle, right?
So we don't need slope value for 0, 0 when both are 0.
We don't need the slope value, yes.
Just we can continue.
No, we will have to count the points, right? This will be fine, right? I am just not normalizing it if it is. If both of them are 0, then only my factor will be 0. And then I can choose not to normalize it. Oh, I have not continued. Actually, the reason is this. Both the factors will not be 0 any other way. This is the mistake. Not. I can just skip that. This should be fine now. I think so. Let's see.
सर empty input का भी
क्या एम्प्टी के लिए भी लूप होएगा क्या ये? Which one? अरे yeah, tell me. Plus 2 will not be in the inside max. So inside max, I'm not having plus 2, right? The problem is this will be your max count is a local maximum, right? So you will have to reinitialize it. By clearing your map. Yeah. I can repeat the duplicates logic, but basically this is the code. So what have I done to handle duplicates is that, see, we are enumerating all points beginning with this point as the first point or one of the points in the line. So when I am counting a line that has this point as one of the points, one of the ways I could count it is that every time I'm getting a line, I just count the other point. Okay. And I keep counting all the number of points, number of this point on that line. How do I count that? One will be for this, and then you will have a dupe for the number of times you get that again. So dupe plus one will be total number of times you get that point in that line. And max count is keeping the count of every other point which is on that line. Right? First of all, did you understand how I handle duplicates? Others? Yeah, or should I write it on the whiteboard and explain if you don't understand how do you handle duplicates? Yeah, now ask me questions.
It will be good if you could explain.
Yeah, I can do that very quickly. So what I'm doing here is, see, when I'm enumerating all the points, all the lines with this as one of the points. So what I'm doing is, in my max count, I am keeping all these crosses that I'm getting. And every time I encounter a dot, which is basically this point again, I am incrementing my dupe. So in all, the longest line which will pass through this, how many points will be there? It will have max count number of cross points. It will have one for this starting point, and it will have dupe for all the other points which are the same as this, which you encounter later. So that's basically what if I have done there, as result is max of result, comma 1 plus max count plus 2. These are the same points. This is the same xy as this.
Yes.
If we declare map inside the loop, yes, you will not be able to. Yeah, I think. Okay, shall we move on? Can we remove map clear? What do you mean? You can, there might be ways of doing that. एक बार हटा के चलाना है, अरे नहीं चलेगा, रो देगा. Okay. Yeah, yeah. If you declare it inside, it will. I am not saying that. See how much bloated this result is. Okay, let's move on. So this is basically one way in which you can use this kind of a search structure wherein you are looking up that value again. Like anything that you are storing and you're looking up again, you can use a hash table for that. Let's do another question. This is more of a, you can try this question on your own. This is 166. We can do that tomorrow. Let's do another question quickly. Let's try this question. I will give you the number. This is 974.
Which one are we doing? 160?
974. 974. So have you read this? Follow with me. What you have to, I will tell you what you have to do. First of all, any ideas? So I will just give you a hint. Use the view of the subarray that I gave you yesterday. What view of subarray did I give you yesterday? Yes, basically every subarray is basically, if you want to represent this array is nothing but this array minus this array. Can you use that? Okay, this is there's a prize for this. You get a cheese burst if you are able to do this in an order and time. Basically using this view itself.
Sir,
हाँ.
suppose we have stored up till now every prefix sum like count of subarrays starting from 0. Basically we have maintained like how many subarrays starting from 0 have prefix sum this.
Okay.
And we are also maintaining a prefix sum.
Okay.
And now suppose in the map the count of the prefix sum that we have is already present. Like I mean to say this prefix sum was encountered before. Basically first we need to divide all, like we need to take the modulo of all the numbers by k.
Okay.
And then all the numbers will be in the range 0 to k minus 1.
Yes.
And and if that's
think about it. It's fine. You're close. Just think about it. Work out some details. So if you remember, what is the view that I gave you? That I told you that if you want to enumerate every subarray is basically nothing but if you are taking this subarray ij, it is nothing but this subarray 0j minus 0 I minus 1. That is basically this particular subarray. So this view of subarray can be used in enumerating all subarrays. So what is, let's even before we go that, let's talk about the brute force way of doing it. What is the brute force way of doing it? That you can enumerate every subarray, which means that, so you for this, using this view, you can enumerate all subarrays. How? By fixing a j. So you can have an outer loop where you have a j, which is basically pointing to the end of the subarray, and every subarray can then basically be, you can then have all the i's which are less than j. So you can go over them, and this will basically give you all the subarrays. Correct? This is how you can enumerate all subarrays. Now think about this view. Using this view, what I can do is I can count or take care of all the subarrays which end with j at once. Instead, so what are the subarrays that end with j? This is the subarray, this is one subarray, this is one subarray, this is one subarray, this is another subarray, this is another subarray, right? So these are all subarrays that end with j. Now, can I take a call for all the subarrays that end with j at once when I am at this particular index? Do you get this? Like, what is the brute force? The brute force is you enumerate all subarrays. Every subarray you can basically find whether the sum is divisible by k or not. That's one way you can do it. Now, I'm just telling you that using this view, what the benefit that you get is that you, whenever you are enumerating all subarrays ending at a particular index j, you can get that, you can optimize some of the decisions that you make just by this. So what I mean to say is, let's say if I'm here and I have stored, let's say if I'm here, I have stored already all the, for all these subarrays, for this subarray, for this array, for this array, for this array, I have stored that particular subarray somehow. Then when I'm at this particular index, what do I need to do to take care of all the subarrays that end with j? I can go over all these subarrays, this subarray, which is basically 0 to 0, then 0 to 1, 0 to 2, these subarrays. I can go over all these subarrays one by one, and for every such subarray, I know, for every such this array, I know that it is basically giving me one unique subarray that ends at j, right? So I can simply subtract this cumulative sum of 0 to j with this and check if it is divisible by k. If it is, then I am done. This will be added to the count. Are you with me so far? Or did you guys lose me? What about others? Do you get what I'm trying to say when I say that you want to enumerate subarrays in a specific order? Basically, what you are trying to do is, for enumerating all subarrays which end at J, what you have to do is you have to take if you want to take care of this subarray, basically this is basically this entire thing minus this thing, right? So what I can do is I can go over this array again, and for every subarray I can do this and check whether this is equals to 0 or not, and this basically gives me order n squared solution, right? So what have I done so far? Let me just summarize for the benefit of everyone. First things first, I told the brute force way is basically you can go over every subarray, and for every subarray you can find the cumulative sum and check if it is divisible by k or not. So every subarray is n square, finding the cumulative sum is n. So a total of n cube time it will take. This is the brute force way of doing it. Now I told you that use the view that I gave you. So use that view to optimize this. How? By using the cumulative sum. So I told you that when you want to enumerate all subarrays which end at this index j, what you can do is you can simply go across the cumulative sums of this array, this array, this array, and for every, let's say this is the array you are considering, you can simply subtract this cumulative sum from this cumulative sum to get the cumulative sum of this, and this will be order 1, correct? So this will be n square into 1, which is order n square time. Right? Is this fine so far? Does everyone understand 2? Is there anyone who has doubts with 2? Now let's talk about 3. How can you optimize this even further? So I will give you a hint. So when you are at a particular j, what are you doing currently? You are going through all the i's, and for every I you have a subarray, and you are checking for whether this array for this particular I is divisible by k or not. Why do you need to go over all the i's? Can you only search i's with a specific property? Because you only want subarrays which are divisible by k. What is that? Yes. So that basically brings me to the next point, which is that now that you have this array, so you have some sum, okay, let's say S1. Let's consider that this particular subarray is divisible by k. This sum is S2. So if this sum S1 minus S2 is divisible by k, then you can write it in this form. Correct? So for a given S1, what do you have to find? For a given S1, you have an S1, right? You have to only iterate through certain S2s, not all S2s. So S2 is S1 minus n into k. Now let's see. S2 can be written as a into k plus r1, right? If you divide S2 by k, this is the expression that you can get. S1 can be written as b into k plus r2. Right? So now if you take this that side, you have b minus a times k plus r2 minus r1 is equals to n into k. So what do I get by this? I get that I need to find. So now let's talk about this. What is this? This is the remainder when you divide a number by k. R1 is the remainder when you divide by a number by k. So this is between 0 to k minus 1. R2 is also between 0 to k minus 1. So R2 minus R1 will also be between 0 to k minus 1. So now for this expression to be true, what can you conclude? That R2 minus R1 has to be 0. Is this clear? I can explain again any part if you don't understand. Others? I just represented S1 and S2 when I divided by K. This is how S1 and S2 can be represented, and I need S1 and S2, S1 minus S2 to be a multiple of K. So S1 minus S2 is this, B minus A into K plus R2 minus R1. So this is already a multiple of K. You want this to be a multiple of K in order for the entire sum to be a multiple of K. Now, but this lies in the range 0 to K minus 1. This is cannot be greater than K, greater equals K. This is always less than K. So what value can you give it so that this entire expression is a multiple of K? Only 0, right? Anything else you give, it will not be a multiple of K, right? So if you understand this, then basically what we are concluding is that for a given S1, you have to find such S2 such that S2 and S1 both give the same remainder. Right? So far so good? Everyone is with me? Is there anyone who lost me? Can you please acknowledge if you get it? It's been a long time since I took some names. Let's take some names. Atharva, do you understand? Harika, Harsha, Meet, Sanyukta, Srifani, do you understand? Yeah. Okay. So now let's see, can we optimize this search further? So now let's see. Now when I'm at a particular J, I need to find all i's such that this particular sum gives me the same remainder as this particular sum. I need to find all such i's. So now when I am coming from here, what can I do is, so one way of doing it is obviously you do a brute force. Every time you find the remainder, go over all the i's. The other way you could do it is that for every such I, whenever you have encountered it, whatever remainder it gives, you can put it in some container. So by the time you reach here, you have all the prefix sums, the count of all the prefix sums with remainder R2, the count of all prefix sums with remainder R1, count of all prefix sums with remainder R3. And then you can simply, for this J, you know the remainder, which is R. Can you just search for this R in this container? And the count, whatever count you get, is basically the total number of subarrays ending at J, which are divisible by K. Right? Do you understand this? So here also I am just searching and inserting. So I need a hash table. So then my algorithm, so now everyone got the algorithm. This is order n. Simple. This is not very tough. Okay, so now tell me, this is fine. I can do that. Everything is fine. But my question in the array, in the question I have been given that there are negatives also. So how do I take care of negatives also? Can you tell me? How do you take care of negatives? Replace what? Replace x. What is x? Where is x? X is the current sum, is it?
Sir, we can add k later on.
You can add k to what? So what is the problem with negative? Let's just think about that. So the problem is, see, 17 is written as, let's say 17 modulo 5, or is written as basically 3 into 5 plus 2. Correct? Minus 17 modulo 5 can be written in two ways. It can be written as minus 4 into 5 plus 3, or it can be written as minus 3 into 5 minus 2. Correct? So what argument, by the way, failed in the previous? We had S1 as A into K plus R1, and we had S2 as B into K plus R2. And we said that S2 minus S1 is B minus A into K plus R2 minus R1. We said that this has to be a multiple of K for this expression to be true. Now, if I have negative numbers, this remainder can be negative. So now, if I'm going by this notation, so what C++ does is, it typically for minus 17 modulo 5, it will return minus 2 as the remainder and not 3 as the remainder. It does not take like this. So you do minus 17 by 5, it will give you minus 3, and minus 17 by, in fact, Java also does this. Modulo 5 is minus 2. This is what C++ does. So the issue is now the ranges have changed. Now R1 can basically take a value from minus k minus 1 to k minus 1, right? And R2 can also take this range. So now there are more solutions to this. This equation, we said R2 is equals to R1 only when our ranges was R1 and R2, the ranges were 0 to k minus 1. Now the range is from minus k minus 1 to k minus 1. So what is the range of R2 minus R1? This is how much? This is minus 2 times k minus 1 to 2 times k minus 1. This is the range of R2 minus R1. So within this range, how many solutions are there? You have 0, you have k, and you have minus k. Do you understand this? How, what is the issue, and what is, how, like, what was the flaw in the argument? I can take questions now if you don't understand. Do you understand? Does everyone understand? Are you still thinking what's the scenario?
Sir, can't we add
k to the remainder and then modulo it by k.
Yes, you can do that. So you can basically convert this to this, and then you are good. I will just tell you what we have done. So for so there are, for negative numbers, there are two ways you can think about the remainder when you divide it by k. So whenever you divide, that's what I was telling you, when you divide minus 17 by 5, it can give you -2 also, it can give you 3 also. Correct? What is the reason for -2 and 3? So if you're talking about -2, it is minus 17 is represented like this. And for 3, it is basically represented like this. So for this case, this is the remainder. For this case, this is the remainder. So what I'm telling you is there are two ways you can handle negatives. One way is you keep it as it is. You let it give you negative remainders. But if it gives you negative remainders, then the entire argument, which we said that this to be a multiple of k, now this particular range is no longer 0 to k minus 1, because R2's range is now from minus k minus 1 to k minus 1. Similarly, R1's range is now minus k minus 1 to plus k minus 1. So this total range is now no longer 0 to k minus 1. It is minus 2 times k minus 1 to 2 times k minus 1. So in between this, you have a minus k, you have a 0, and you have a k, for which this entire expression will become a multiple of k. So if you plan to keep this as the remainder, then what you can do is for a particular I, you can find all from the map, you can find all the counts of all the numbers which have a remainder of 0, which have a remainder of R1, or R1 plus k and R1 minus k, and sum all this. This is one way you could do it. The other way you could do it is that you could take it as positive. So once you get a remainder of -2, you can simply add whatever your remainder you get, you can simply add k to it if it is negative. So R plus k mod k is still R mod k, right? So when you add k to it, you will now be positive. And then you can simply check for a given I for the same R in the map. Both ways you can do it.
So can we take the absolute value?
What absolute value of what?
Like if we get any negative value, just take the absolute value and then check the remainder.
Check the remainder when you take absolute value, and then
Like our aim is to get the range between 0 to k minus 1, right? So if we get any number which is negative, we'll just take the absolute value and then mod it by k. So we'll keep the range as it is.
you will take the absolute value for -17, you will take 2. That is not right.
Okay.
-17, you can either take -2 or 3. Yeah. So does everyone understand these two techniques? Let me just quickly code it, and then we can take questions. I think a lot of your queries will be resolved if we code it. So let's do the negative wala first. Okay, so this is basically we are allowing negative remainders. So if you are allowing negative remainders, let's have a map to increment the counts. Okay, so this will basically be, it will keep the remainder and a count. Okay, now what you can do is you will obviously, as I was telling you yesterday also, for the zero empty, you would have a remainder of 0, so you will have a count of 1 for that. This I think we talked about yesterday in detail, right? So now I can go over them. For every I will have a cumulative sum. Now I have S2. This is S2. This is S2 now. Now for this, let's just take the remainder. So this, if we take the remainder, it might be negative also. So now what I will do is, I can simply have a count which is 0 to start with. First, same remainder. So same remainder will be plus equals m of remainder. Then remainder plus k. So count plus assign m of rem plus k. And then you can have remainder minus k, which will be m minus k. And finally, you can put this remainder. So m of rem plus. You can return the count. This is one way you could do it. What is the issue? The issue is that even if you don't find it, you will. Can someone tell me what's the issue? This is a minus. There is a typo. That's the issue. Tell me now. Is this, first of all, is this clear or yeah, Bhuvan, tell me.
Sir, don't we need to check if remainder is present or not? Like,
so by default, if it is not, you should do that ideally. You should actually check if m dot find remainder is not equals m dot end. Then you should do this. That's true.
Why it is giving correct answer here?
It is giving correct answer here because even if it is not present, what it will do is the first time you reference it by the key, it automatically assigns it, or it automatically inserts it with a value of 0. So even if m of rem is not present, it will count 0 against the name.
Okay.
And but the problem, I mean, this can lead to problems. You should not do this. The reason why we are good is because we are incrementing the count by m of rem. So m of rem. So now basically what I'm trying to say is, if you do, if m dot find m, let's say if you remove this and you have this, and let's say remainder was not there. Okay. So, and you did this. Now if you if you check whether it was present or not, it will return that it is present in the map. This will be true, is what I'm trying to say. Because even though remainder was not present and you have not put it in the map, that's because the first time you reference it by that key, it puts it in the map with a value of 0. But we are still fine. Why? Because we are just doing a count plus equals. So even if it is like not being present and being present with a value of 0 are equivalent, right? For us.
So it will create some redundant entries.
Yeah, it will create redundant entries in the map with value 0.
Okay.
But if you were, let's say, just checking whether if it was present, if you were doing a count plus plus, then it would have given you a wrong answer. Right? If you were just counting how many of them are there, then it's wrong, because even if it's not present, you would have counted it. So you should always, this is not a safe programming way of doing what I have done. You should always do this.
Okay.
Disclose it in this. And unless you find it, you don't do it. Do you, like, do others understand what Bhupendra asked? This is a valid question and might come up. Where are you guys? Are you guys alive, awake, slept? Yeah. So did you understand what Bhupendra said or asked? And did you understand the answer? And did you understand this? Ask me, which parts do you want me to repeat? Let's quickly do it. Yeah, Harsa, I can repeat his question. Okay, let's come back to his question later. But first, do you understand this logic? Can I have acknowledgements from 28 of you, whoever are alive, if you understand this logic? Everyone understands this? Another way of doing the same thing could be that, how do you do it? Now, if you are taking the positive way of doing it, what you could do is that if your remainder is 0, you could increment it by k. And then you don't need these two lines. This is also another possible way. This is the first way that I was talking about. Do you understand this? Here I am ensuring that I always keep positive remainders. So if I am always keeping positive remainders, then my range is from 0 to k minus 1. And if it is 0 to k minus 1, there is only one solution that's possible, which is 0. If I was not ensuring positive remainders, then things were tricky. You had 3 possible values for the same expression. So you were checking for all those 3 values. Okay. Can I have acts for people who understand this? Now the second approach. Yeah. Yeah. So that's also another way of doing the same question. All right. So I can now, so I'll just summarize what we have covered today so that we can continue tomorrow. So today we looked at a data structure called hash tables, which people have defined in some way. And we looked at how we can use hash tables for problems. So basically we looked at one single structure, which is that if you want to reference something that so this is the structure that we saw. If you want to refer to something which you have already encountered before, then you can store it in a hash table. This is basically the pattern that we saw in both the questions, right? We were referring to the same line. So we thought we might as well store it in the hash table. In the second question, we were referring to the same subarray. or the same remainder. So we said that we might as well keep it in the hash table and look it up whenever we need it. Right? So this is how you can mentally model one type of question that we did. And in the process, I just gave you or reinforced the view of the subarray that I gave yesterday also. This is a this is a good way of viewing subarrays and helps solve a lot of problems. Tomorrow we will continue with more applications of hash table. So we will do questions, and then we will move to binary search trees and we'll do questions. There will be one lecture which is for DS design, which is data structure design, which will be, I think, after day after tomorrow, wherein we will design data structures using things like you will design some systems based on these data structures that you have learned: stacks, queues, LLs, hash tables, BSTs. We will code them also. So this will be different. This will not be system design questions. These are basically you have to design some complicated data structure. You will use these as builders, basic builders to design. Tomorrow is Tuesday, right? We will have DPP discussion on Wednesday. Okay. Yeah, it's not 12. All right, I think we are done for today. Thank you all for joining. People who have questions can stay back. I can stay back and answer your questions. Yes. Yes, wiggle sort we can discuss. So we could do it in two ways. Wiggle sort. We could discuss it now in the class. That's one thing. And the other way we could do it is that we could have a mock interview on wiggle sort, and I can share that video with you. So you can see systematically how we are approaching that question, and you will see a code also towards the end. I was just thinking about it today evening. Like mock in the sense that two of us, basically two from the instructor side, one will be taking the interview, other will be giving the interview, and basically he will ask it's mostly scripted. It will not be like an impromptu. It will be a scripted interview mostly. So the interview will proceed in that manner that he will incrementally build a solution similar to what we've been doing yesterday we were doing, and he will arrive to the final solution with help from the interviewer, and that will be like some 10 to 15 minutes, 20 minutes video, which we are planning to build, and we can then share it with you guys. You can see it. We're planning to do this for some questions, some like questions which can be thought about incrementally like this, so that you can actually see how we are incrementally reaching the optimal solution instead of, okay? So that would be better, right? You can watch it. That will be, and if you have any queries, then after that you can come back. So that idea is good, right? I was planning to have some mocks on some of these questions. Like this line wala question is also one question which you can build incrementally, like properly, giving a structure from the most naive solution to the most optimal solution. Right? Similar to how I explained in the class. Similarly, if you see yesterday's questions that we did, yesterday's first question also you can build incrementally. Generally, any interview question you can do that. Generally, that's how they will ask you. So I'm planning to release some videos on some of those questions, and you can check them out. Okay. Yeah. So let's do wiggle sort in that manner then. Okay. Anything else? We can have a hackathon tomorrow if you guys have time. Okay. I'll put the details in the group.
Sir, about the mock interviews, I had a doubt that actually my interview is scheduled for 2 p.m. on Sunday, but that day due to something my interview was not taken. So I need to like apply for another slot. So will you guys be allotting me a slot, or should I go to the Calendarly link again and
But you will not get any slot now in the Calendly, I think, because it's already booked. But yes, I will make sure your slot is booked. Okay.
Okay, sir. Thank you.
That's on me. So mock interviews will plan to schedule it in phases, like team A, team B, as some one of you suggested, right? Let's do it in that manner then.
Okay, sir.
Yeah. So okay. Anything else? Any more questions?
No, sir.
No. Others?
Hello, sir.
Yeah, Bhupan, tell me.
Sir, how can I contact my mentor? Like,
you don't have his number?
No.
Who's your mentor?
It's Kaushik, sir.
You guys don't have the numbers of your mentors?
Sir, we have the numbers.
But I told them explicitly to provide you numbers also, right? The person who allotted.
Sir, we do have numbers in the Google form list, doc.
Yeah, I mean, just find out. I think numbers have been provided. If not, then I will tell them. Like, tell the person who is doing it.
Yeah, but I tried contacting Kaushik, sir, but I did not get any response. So.
WhatsApp? You called him?
I just contacted on WhatsApp.
You can just give him a call once, maybe 5 minutes, he will pick up. Could be okay. Just try it once. I will ask him also. So you can. That's why. So you can open if you want somebody from our team to monitor that, so that your mentor also is not slacking off or is giving you enough time. What you can do is you can create your own separate channels with your mentors, all of you, like whoever, like 3 or 4 of you who have the same mentor, and then you can add one person from the team into that channel also, at least one person, so that if you ping and the mentor does not reply, then we know that he's not replying, right? You can do that. WhatsApp group or Slack channel, anything you can do. In fact, your mentors have been told to do that, so if they don't, you can also go ahead and do that. Okay. No. This is DSP3 exclusive talk. Yeah, this is not DSP2. Yes. Yeah. Any more questions? All right, then. I will see you guys tomorrow with more questions, hopefully difficult questions, intermediate questions. And good night. Take care.